Alright, so here are the structural formulas, again, for those 6 examples that I had you guys doing there. And as you can see, again, we have these 2 or 3 lines which connect our atoms, depending upon how many pairs of electrons that they're sharing. Okay. Now we're going to deal with some metallic bonding. So most metals are solids at room temperature, which means that there must be strong attractive forces holding the atoms of a pure metal together. So metals do not form a covalent or ionic bonds with each other or other metal atoms. Okay? So in metallic bonding, all atoms share all the valence electrons. Okay? Valence electrons are delocalized, which means that they are free to move from one atom to another. So you can just imagine that all of the nucleuses are there and all of the electrons are free to float around between them. This is actually one of the reasons why metals are so great at conducting electricity. Okay? So metallic bonds are made up of a network of positive metal ions in a sea of electrons. Okay? A metallic bond is the electrostatic force of attraction between the positive metal ions and the negative sea of electrons. So this theory helps explain the properties of metal. So for example, they're good conductors of electricity, heat. They've got good ductility and malleability, and this is all because we have these positive, the positive metal ions and the sea of electrons that floats around. Okay, so here we've got our depiction of a metallic bond model. Okay, here are our metal cations. So these are essentially the nucleus of our metal atoms. And then here we've got our sea of delocalized electrons. Okay, so these guys are just floating around, trying to serve the octet rule for various metals, but they're allowed to kind of float around in between all of them. Okay, now we're going to look a little bit into the nature of chemical bonds and electronegativity, and just because it's such kind of separate from this particular thing, or we're going to start a new video in order to deal with this. Alright, so that's